So like Uni said, I also can have different hats on. One of my hats is Managing Director of Unified Automation. And we are probably known for SDKs. And I will talk one slide about what we do. But today I will talk about OPC UA security management and what we do for that, and what we will provide as a product in the future. So Unified Automation is mainly known for development tools in different programming languages. And like you see, Java SDK, there we work very close with Process. So Process is also a reseller for our SDKs in Finland, in Scandinavia. So this is our main business. But I will have a slide at the end where you will see how it fits into our overall product strategy to have this security management tool. But so my agenda for today is like give you some basic concepts for security management in OPC UA, and what OPC UA provides as a standardized, centralized security concept. So that's part of the OPC UA specification. And then what we are working on as a product from Unified Automation to implement that security management model in a product that you can use as a standalone installation to manage security in a production environment. And then also what we are planned for additional features in next versions. So the basic principles of OPC UA security is based on a so-called PKI, public-private key infrastructure. And these certificates, these keys are used for different things as basic basic security concepts. And the first one is, how can I trust my communication partner? How can I identify my communication partner? So the public key of an application, OPC UA application, is used something like a passport. And in a simple case, the client and server applications have trust lists where they have like a white list of applications they are allowed to talk to. And then you have, for every public key, you have a private key, and like what the name says, private keys means you keep that private inside the application. And in the best case, you have some crypto storage inside the device that makes sure the private key never leaves the device. And the private key is used for two things. It's like to make the communication private, you need to encrypt the messages that are exchanged. So the private key is used to, the public key of the sender of the message is used to encrypt the message, but only the owner of the private key can decrypt the message. So that's one basic principle of communication security. And then the second thing is to creating signatures. The private key of the sender is used to sign a message. So only one application that owns the private key can create valid signatures, but all applications that receive messages can verify the signature by using the public key. So this is not specific to OPC UA. This is what you use when you open a web browser. That's when you use like email encryption. So whenever you use cryptographic in IT applications, you probably use that based on the PKI infrastructure. So that's nothing special for OPC UA. In a lot of OPC UA applications today, you do like the point-to-point communication and security configurations, just putting the public key of the trusted communication partners into the trust list of the server for the clients, and the clients put the trusted server in their trust list. It's very easy to configure, but you can imagine only easy if you have just a few communication partners talking to each other. If you have hundreds of servers, hundreds of clients that need to talk to each other, you need a more centralized concept to manage security. And in a PKI infrastructure, this is called CA, Certificate Authority, where the CA signs application certificates, and the server that wants to trust all these clients just trusts the CA certificate. So only the certificate authority, and all clients that have a signed certificate, they are automatically trusted by the server. So it's very easy to add clients, and you can do that by just have a centralized CA that hands out signed certificates to application when they're installed. But you have another problem here. How do you get rid of a client or of a server out of the communication? And for that, a CA has a concept called certificate revocation list. So a CA certificate is really only valid together with the revocation list. So you still have then the problem that you need to distribute this revocation list. They are updated frequently. You need to update on all applications. So you need a way to not only to install applications, you also need to update trust list of applications. And in OPC UA, OPC UA Part 12, there's a concept of a global discovery server, and it defines different interfaces. There's one interface called directory type, and it's used to register applications and to query applications, so it's the discovery part. And there's a second interface called certificate directory type. And this interface encapsulates a CA with the OPC UA interface. And this, like I said, this is defined in OPC UA Part 12, and there's the typical functionality, like it's to create send a signing request. So that means the application asks the CA to create a signed certificate. Or the alternative is to create a key pair, but this is not the preferred one, because then the private key is also provided by the CA, and typically the private key should not be available somewhere. But there are scenarios where the IT administrators want to have the private keys available. But like I said, the preferred way is that the application just sends a signing request, so that in this case the private key does not leave the device. And then there's some methods to get the trust list to update the trust lists and the revocation lists. And there's also important thing is in the CA's environment, you frequently need to update the application certificates. So there's also a method that every application can check if a renew of the certificate is necessary. And so the general concept is an application, when it's installed, either client or server is registered with the directory type as a registered application, and then there's a signing request sent, and then the certificate of the application is updated with a signed certificate. And this installation needs administrative rights. So you need to have administrative rights on this central server to do this security, this certificate rollout. But then you need frequently update the trust lists and revocation lists, and this is done by clients and servers with this get trust list, and so this is executed frequently, and this does not longer need administrative rights. It's just the application authenticate themselves by their application identity that is known to the GDS, and so they can do that on their own, and that's what we call the pull model. So the applications pull updates from the server, but there's also so if this is a client functionality, if you have a server that has no client functionality at all, we also define the interface on the server side, where a tool can push these updates and the certificate, the signed certificates into the server, and that's what we call the push model in the GDS. So a GDS from OPC UA standard point of view encapsulates a certificate authority with the OPC UA interface and application registry, and there's a pull model and a push model for client and servers. So what we like started like in unified automation, we are developing a product that is then used to manage these applications in a standalone installable product. And one of the components of the central GDS is a directory and a certificate management component. So they will implement the standard interfaces defined by OPC UA. So this is for the pull model, and then we have also a GDS client that is part of the central component, where you have an outgoing interface to talk to servers through the server configuration type, and that's implementing the push model. Then we have an administrative tool to manage the GDS, and also a client proxy. I will explain how this is used 2 or 3 slides later. So the one use case is the pull configuration model. So in this case, you use a administrative tool of the application. So for a client, it's typically like some configuration GUI as part of the certificate management of the client. For the server side, it would also be possible to use the application that is shipped with the GDS to register the server. But if you don't have the push model in the server, you still need to have a way to update the certificate. So therefore, it's typically, in the case of the pull model, it's a tool provided with the OPC UA product that is then used to register the product at installation time, to get a certificate from the GDS through the standard interfaces of the GDS defined by OPC UA, and then to update the certificates. There's the get trust list and the updating the trust list and the revocation list for server and client applications that have the pull model integrated. Then for the servers that have the push model, we can use the standard administrative user interface to get the information from the server, to register the application with the GDS, to start a signing request, and then push the certificate updates down to the server. So that's the initial step. And after that, this GDS client inside the GDS is set into push mode for that server, and then it's automatically updating the security configuration of the server whenever it's necessary. So that's typically when the GDS creates a new revocation list or it needs to renew certificates. This is pushed automatically. So after installing the server the first time, after that everything is done automatically by the GDS from a central place. But there are cases where the central GDS is not able to connect directly to the server. So in this case, the update mechanism is done by this proxy that is installed, like for example in a local network that is able to connect to the server. So in this case, this proxy is acting as a pull application to the GDS, but as a push application to update the server side. So this is the basic functionality of a OPC UA GDS, like defined in the OPC UA Part 12 specification. There are additional features that are part of OPC UA 104. So one is a handling of single sign-on tokens in a centralized user management. So we added a user token called JSON Web Token. So that's probably also what you used already in websites. So if you log on to a website like with a Google account or Facebook account, use exactly the same technology behind. And we have the protocols for that in OPC UA integrated, but we have also a variation that is purely OPC UA. And in this case, the server that trusts such tokens from a centralized server needs to be configured to trust such a token server. And when a client connects to a server, it always calls get endpoints to find out what are the security requirements for connecting to that server. So the server can provide the information about the token server inside get endpoints. So that's all standard OPC UA functionality. And then the client can request such a JSON Web Token, JWT, from that token server through a standard OPC UA method on an additional interface that we defined in OPC UA 104 called Authorization Service Type. And this can then be used to establish the connection with the server. The advantage here is you can manage the users and the passwords in a central place. So you don't need to manage the users on the servers, you only manage them in a central place. And the servers only need to trust the token server, and you can manage the allowed relations and the allowed roles in a central place for the OPC UA communication. So this is one feature that was added in OPC UA 104. And the second feature that also requires some centralized security setup is security for PubSub. And in the PubSub concept, you have publishers, you have subscribers, you have some middleware. Could be a message broker, could be just for UDP, just switches. But since you have a one-to-many or many-to-many communication, you cannot establish security context as a point-to-point connection. We have in OPC UA PubSub, we have a concept of a key server that hands out session keys for the PubSub communication. And that allows to share a key between several subscribers, but potentially also between several publishers in a so-called security group, which is security context for PubSub messages. And this security key server can either be part of the publisher. So in this case, you share the keys just between all subscribers, but every publisher has its own keys. But if you want to share keys also across publishers, you need a centralized key server, what we call security key server. And so this is a second security management piece that requires some centralized component to manage that second scenario. And so what we plan as a second version for the GDS is to be able to manage really all roles of OPC UA, to manage clients, servers, publishers, and subscribers, and the necessary security context for it. And so we have to manage the applications. So what are the applications that are known in the network and you can trust? And that the GDS also allows you a secure discovery. So it only what is registered shows up, and registration requires security administrative rights. And also the access to the registry is secured with OPC UA. So you can apply full security also to discovery. Then we have the certificate directory type for the certificate management, application instance certificates. Then we have the authorization service type for the centralized user management. And the fourth feature set is like the PubSub key service type, which is required for the security key server. And so this is the let's say currently the feature set that is defined in OPC UA specifications for centralized security management. There's potentially more coming up in the future for that part. So I promised to give you the big picture. So the products and services Unified Automation provides is, first of all, training to allow people to understand OPC UA. Then that's our main business, to support developing OPC UA products. So we have different libraries. We have also supporting tools like UA Modeler is a modeling tool that is very popular. And UA Expert was already mentioned, I think, in the Beckhoff presentation as a test tool. But we also have tools like UA Gateway. It's protocol converter between classic OPC and OPC UA, which is especially for the transition phase from classic OPC to OPC UA, a very important tool. But also UA GDS is for the operational phase of products is a very important component in the future, especially if you do bigger rollouts of OPC UA with a lot of clients and servers in one environment. Okay, thank you for listening.
Thank you. Questions?